Okay, again, we are picking up with the study of algebra, and by and large, the study of algebra has to do with certain operations and certain sets. And so today we're going to focus on operations of addition, subtraction, multiplication, even division. And the type of sets that we're working with, we're not going to work with real numbers right now, but rather we're going to work with algebraic expressions. And namely, we're going to deal with rational expressions. So I know you understand how to add and subtract, multiply polynomials, but what about if they're written in fractional form like this? And I know that I know you already understand this, but you may not understand why it works out. So a lot of people look at the 54 and 24, you divide by 6, divide off an x. But I'll challenge you that what you can do is rewrite this in this form. Okay, so I've written it in a factored form, and then I'm going to use what's called the commutative property of multiplication. Okay, what does commutative mean? You move them around. So I commute each day from Owatonna, which means I drive back and forth from Owatonna. Okay, so I commute. Well, these terms can commute because it's multiplication. So I'm going to write this as a 6x times a 9x over a 6x times a 4. Okay? Is everybody okay with that? So I just move them around. You're allowed to do that in multiplication. 6x over 6x is just 1. So that's really what you're doing when you are reducing these type of expressions, is you're looking for which parts make 1. Because 1 times anything is just itself. So you can see in this situation we get 9x over 4. Okay? And so you can see in this scenario, we have 2 times x squared times 4 times x minus 3. And then we have 4 times x minus 3. So, you know, as you write it in that nice factored form, you can see exactly what gives you 1. That gives me 1, so I can cancel it off. So you get a 2x squared. So that's why we could just cancel stuff, because we find what makes 1 as we divide it, okay? So how about letter C? What do I do first there? Yeah, I must write it in factored form, so I have that opportunity to use the commutative property of multiplication. So if I take out that 5, I'm left with, and on the bottom I can take out 10x, and I'm left with x minus 4. Now, you know, once we do that, it's simple enough to just cancel stuff off and see 5 over 10x is going to give me 1 over 2x, and that's my final answer. Now, if I'm not a very disciplined mathematician, or if I'm just really confused at the moment, what might I do to letter D that would be completely inappropriate? Yeah, just go like that, right? Yeah. Yeah, that's just wrong. Okay? Because if you did like, say, 2 plus 4 divided by 2 plus 1, okay? Well, could I just, you know, I'm just going to cancel those off. It's just 4. Well, that's just stupid, right? You can't do that. So we're not going to do it here either. We're going to write it in factored form. We've got x plus 3 times x minus 3 divided by x minus 2 times x minus 3. You see the x minus 3's cancel them off. And I will get people to this part, and they will still cancel this off. And so 3 divided by negative 2 is negative 3 halves. That's my answer. Boom. Okay. No. No. It almost pains you. It's like looking at the solar eclipse. It like burdens your eyes. Okay. No. What just happened? Stop it. And so we get that. Okay. Yeah. All right. Okay, so if we multiply, nothing really changes. And the nice thing is, because we have commutative property of multiplication, we can deal with, you know, pieces that are in other parts of the expression. So 4x over 2x makes 2 over 1. So those are gone. And then 3 over 9 makes... I did not just cross multiply. That's not cross multiplying. Okay, that's if we have an equal sign in between. 2/3 of my answer. Here it's really nice. I could just cancel off these x plus 2's. And then 4 over 12 is 1 over 3, so x minus 1 over 3. Okay. But for letter C, I have to actually do a little bit more factoring. So x plus 5 times 3 times 3x plus 1 divided by 3x plus 1, x plus 5, x minus 5. So once it's written in its factored form, then it's nice to cancel stuff off. Some of you guys love doing this because you're list makers, and you like to cross things off your list. So you like this stuff because you get to just cancel stuff off. You try letter D on your own. For letter D, you should come up with x minus 1 divided by x plus 1. Again, do not cancel off the x's and come up with a value of negative 1. That's completely wrong. Okay. All right. Okay, we've learned how to simplify and we've learned how to multiply. Now let's do divide and then add and subtract. What's different if I divide? Yep. I got to multiply by the reciprocal. So if you think about it, if you take 6 divided by 2, that's the same as 6 times 1/2. So I don't flip the first number, I flip the second. Okay? This type of problem tells us what we're supposed to do when we encounter fractions. We multiply by the reciprocal. So I have 12 over 6x squared. And that will give me 4 times 1 over 3x, or 4 over 3x. Instead of rewriting the whole problem, I like to just make a big multiplication sign and then flip everything. And then you can see what cancels. The x plus 1's, the x minus 2's. And don't forget about the x that's sitting right here. A lot of people forget about that when they write their answer. For letter C, you can see the factoring. Now, I bet I've done this no less than half a dozen times when I write my result. But instead of writing x minus 1 times x minus 3, do you know what I write? Sometimes I write this. Why would I do that? I just get used to always ending up with fractions. And so I'm like, oh, x minus 1 and, I think to myself, oh, x minus 1 and x minus 3. So I write the answer like that. When, they are both in the numerator, so make sure that you pair them up accordingly. Please do letter D on your own. should get x plus 3 over 3 times a quantity, x plus 4. So tomorrow we'll get to the more challenging stuff. So if you remember from last year, maybe you encountered this at some point. Something like that, maybe? Yeah, 1, yeah. So that we're going to do with complex fractions tomorrow. Okay. So the last thing we need to teach you to do is to add and subtract. In order to add and subtract fractions, you must have. So I'll multiply top and bottom here by 2. And I get 6x minus 10 plus 8x minus 1 all over 6. 14x minus 11 over 6. Can I simplify that at all? What if it was a 14x minus 12? Yeah, you could factor what out of the top? 2 out of top and bottom and cancel. Okay. For letter B, it's okay if the denominators are an algebraic expression and not simply just a number. Here they're the same. All I do is I just write 2x minus 3 all over x plus 4. What about letter C? Yep, x minus 1 over x minus 1. And here, x and x. Now, I will say that I do get people every year that when they see this, they'll say, oh, this is just missing a minus 1. So, we're going to have 2x plus 2 all over x minus 1 then. Okay? No, you would not do that. And so we get 2x squared. We get a 3x, get a minus 3 over x times x minus 1. And I will say that if you wrote the bottom as x squared minus x, that'll be fine. But traditionally, when you have rational expressions like this, you often leave the denominator factored. And you'll find that to be much more useful later on as we investigate other types of stuff. So 5 over x squared minus 4, 5 over x plus 2 times x minus 2. So what do I have to multiply top and bottom by in order to create common denominators now? Yeah, just the x minus 2. We don't have to do the full x squared plus or minus 4. If you did, it would work out, but there would be some simplifying, extra simplifying that you would have to do. So I have a minus 6x and a plus 12. And so we get 5 minus, wow, I've really messed this problem up, haven't I? So we get 5 minus negative 12 is 17, and we have a negative 6x over that x plus 2 times x minus 2. There you go. All right, so nice quick lesson today. You have enough time in class to probably get your assignment done. A lot of students in other classes did. 1 through 13 odd, and then those odd, and then 33 and 34. I believe that your assignment, again, that the book pages are online if you'd like to see those there. And we're looking at doing a test sometime the week after Labor Day, okay? So I would say right now my guess is about Thursday after Labor Day would be about that time. But I'll let you know more definitively for sure by Wednesday this week. Note that we do not have school on Friday, do we? Nor the following Monday, so you have a nice 4-day weekend coming up. Get to go